Well, thanks, Agash, for the warm introduction. And thanks for the invite. A little bit of background. I'm going to start with a little bit of background on myself, as I guess mentioned. So I did spend some time on financial industries, payment systems, card systems, plastics, and then investment management organizations, Vanguard, TIA, and now I'm at Wealth. And first of all, what I would like to do is introduce Wealth. But before I introduce Wealth, I want to mention that I have three objectives today. Number one, I want to talk about B2B targeting and who and how do we define who at Wealth. Second, I want to talk about how. And third, I want to talk about how do we put all these things together and what it is to work on on a startup organization where things move really, really fast, when you have to build a brand, you have to build reputation, and so on and so forth. So let me just start by telling you who's Wealth. And we are a startup. So we launched 2 years ago in 2021, and we actually launched our product early last year. Yes. So and the idea of the Wealth is our first, what I call end-to-end digital estate planning. And for those who have done estate planning before, congratulations, I try myself. It's a really, really hard environment to navigate or a financial decision to make. So anyway, our plan was to launch an organization that would essentially facilitate the process of estate planning. And as we saw in many presentations today, financial decisions are extremely complicated. Imagine you doing your estate planning. If you cannot even talk to clients in some organizations to add beneficiaries to their 401k, imagine what it is to do estate planning. It's actually more complex. But our job here is to simplify the whole process. So first of all, as we start simplifying the whole process, we thought about our launch strategy. And as we launched, we have many ways of launching our product and getting ourselves known in industry. First, we can go direct to consumer, but direct to consumer requires a ton of investments in marketing, investments in pretty much marketing, direct marketing, and all you can imagine. So one of our goals was actually to start engaging with financial advisors and IRAs. And the reason why we wanted to engage with financial advisors is because these individuals already have relationships with their clients. And so we can distribute our product in a much easier fashion way, if you will. And at the same time, providing the extra layer of value that an advisor can provide to specific individuals. But as we thought about going to market, we thought about IRAs. How do we think about IRAs? IRAs is a massive industry. So 15,000 investment companies, IRAs in the US currently. And as we think about how do we make sure that we are maximizing our return on investment on targeting, we got to make sure who do we talk to? How do we talk to? The universe of IRA, I just put some numbers over here just for you to have an idea of what are we talking about. So IRAs, the size of these firms, these registered individual advisors, can vary dramatically. The way you should think about this is these are smaller offices or small offices with on average 30 to 25 individuals that are providing financial advice services to direct to consumer. And that's what I originally thought. But when we look at the diversity of IRA firms, we found many different operating models out there, which I'm going to demonstrate throughout the presentation. But just so you to have an idea of the distribution of number of employees per IRA firms is massive. Like 80% of the firms do have less than 30 employees. So what that means is we have to be very surgical and very precise. And when we talk to these particular companies. So as somebody on my team used to say before, we have to make every dollar work harder. Okay. And that's our goal, to optimize our investments. So what do we do first? So first of all, let's talk about data. For a startup organization, as we have no data, we have the options of we can go to market, buy a lot of data, or we can, try to grab from public data information, public available information. So we decide to endeavor ourselves and build our own data based on what's available at the public level. So we found, of course, I think most of you should be familiar with ADVs and SECs, and we collected a lot of data from SECs. We put together in this interesting, I don't want to say data warehouse, but data lake, if you will, because this data is unorganized. There's good things and bad things. The good things is the abundance of data that you have at the firm level and sometimes at the advisor level is massive. The bad thing is this data is not organized. So our task number one was really to grasp all this data and organize in a way that we can subsequently use to drive insights and finally our strategy. So that's the first goal, done it. Very happy what we built. And here's some information of the data that we have at the firm level. We have a lot of details at the firm level, book of businesses, types of clients, AUM. We have their investment philosophy, if you will, to some extent. We can check how much what's the percentage of investments in ETF, mutual funds, and other securities. So there's a lot of information out there. And we have limited data at the advisor level. Employment history, exams, and some licenses, and some other descriptions of their activities. So goal established and completed was organizing this data in a way that we can use to optimize our efforts for targeting. But what is our, one more thing is please stop. I can't see the chat now, but please stop and ask any questions throughout the presentation. Okay, so I like to have something very, very dynamic. I know it's after lunch, but please feel free to ask any questions. So what is our task number one, as I mentioned? So how do we think about optimizing our targeting? I'm not sure how many of you have worked on smaller organizations that are, number one, try to be known, but number two is having conversations with individuals that have a little bit more financial literacy, for example, like our advisors. So the one of the things that for sure is we have strategies we have for outreach. Either we're using direct marketing or digital marketing or personal sales. When I talk about personal sales, is really reaching out to somebody completely out of the blue. Hey, you want to know more about wealth, you want to know about digital estate planning. And those conversations can turn, it's a very interesting how we measure the results of these conversations. Conversations can go really well or can go really, last 2 minutes. And these are some of the things I wanted to talk about on this presentation. But we thought about, okay, this is our life cycle process for targeting, for example. We have outreach. Out of these outreach, we have scheduled conversations where we typically talk a little bit about our product. We have a little bit of deep dive we call personal meetings. These personal meetings are online or in person, where our sales teams will go in and demo our product. And then finally, we go to a winning round where we win the relationship or we sign up an advisor for using wealth.com. So this is no secret to anybody, but we need to optimize this whole flow over here. So the way we define this is, hey, you know what? If today I'm having, I have to reach out to 100 individuals to get 10 conversations. I have to have 10 conversations to schedule 3 meetings. How do we maximize the amount of, and so on and so forth? How do we maximize the amount of winning? So our process was, let's reverse engineer the process and see what we can influence. So we said, you know what if we keep the same level of effort on the outreach side, like keep this N of outreach fixed, and we start marching backwards, but we find ways in which we can maximize the personal meetings. Why we want to maximize personal meetings, you might ask, instead of maximizing winning? Well, because we thought in the beginning, number one is the awareness is really, really important for us. But more importantly, the understanding what the appetite of these types of solutions for advisors is, it was crucial for us. So we decided to optimize this side of the puzzle. So, and therefore, of course, bringing a little bit more reward to our sales individuals as well as our digital marketing, which is, spending time and money. So what do we have? What did we have in the beginning? So when we launched our product, we started having conversations. This cycle was working, and having these conversations, we start gathering a lot of feedback from particular advisors saying, yeah, I love it, I want to sign, or I'm not interested. I usually deal with lawyers. So as we start gathering all these individuals, we start gathering this thumbs up. I like to call it a thumbs up. And the thumbs up was great conversations. We also had some not so great conversations, as any business, of course. But our problem was, our tip number one for us to optimize the overall process was, can we take these two labels, if you will, and start building naturally classifiers? Well, you won't work. For us, when we start doing this, things didn't go very well. Why? Because the universe of advisors that we didn't talk to was massive. Just for you to have an idea, today in the US, we have 15,000 firms, RIA firms, and a total of 391,000 registered advisors. So we haven't talked to all these advisors yet. So we needed to define something that says, hey, what if we find a cookie cutter? What if we just find a carbon copy of the positive conversations, and see if we can find similar advisors that will be accepting having a personal conversation with us. So, of course, one of the things that came to mind was one-class models. And one-class models, is generally for you to find outliers. It's typically used in the industry of outliers. But the way we use this is a little different. So we had a lot of great conversations. And our goal is, can we maximize the learnings of these great conversations and maximize these vectors of advisors and firms that we have, or learn what these data points have in common, so we can find similar advisors to have better conversations. So there's a lot of research happening on one-class models. I think this is a phenomenal topic for outlier detection, and eventually, when we have these types of problems where your why is incomplete, your labels are pretty much incomplete. So this is the route we decide to choose. Once we decide to choose that route, we talked about, okay, so now what? Now what do we do about it? So we have our models, and we have our positive conversations. We know who they are, we know what we've done. So what do we do about it? So we decide to approach two different techniques and test two different techniques. One is isolation forest, which does a really good job of isolating points that do not belong in a distribution, and one-class SVMs. I think there's a lot of more techniques out there, but as a small organization, we needed to move very, very fast. So, and there's one thing that one parameter that these two algorithms needed. You need to know a little bit of the contamination rate. What is contamination rate? So contamination rate is, think about when these models were made for detecting outliers, you need to know how many of these great conversations really don't belong in a great conversation. We're probably outliers of those great conversations. And that's what it's a parameter that these two modeling techniques actually use. So our approach was, okay, let's test it out, the two different models with the minimum amount of labels that we have, and see what we get. And how do we determine our contamination rate? So isolation forest and one-class SVMs, we actually use two different metrics or to analyze our confusion matrix. And the confusion matrix this is a summarization of our confusion matrix. So first of all, let's look at the corrected classes classified. So with the positive feedback that we had, we wanted to make sure that when the model says, yes, you belong in that decision, in that circle of inliers, these are the numbers that we have. We have roughly, as you can see here, 91% at 5 contamination rate, 10, 12, 87, and so on and so forth. So we notice a little bit of pattern here on the isolation forest. The more you tell that the models have higher contamination rate, you see, of course, your outliers probably not, your model or label is not belonging in that decision boundary, which is kind of intuitive for us. The second metric that we used was, what's the percentage of population classified as outliers? And why is this metric is important? Is because this is similar to when you have fraud models or you're modeling events that are very, very rare. You can have, and I see this in industries where, hey, I achieve a 99% accuracy on my models, but I'm classifying every single thing as non-fraud when we measure fraud in basis points. Very similar problem that we had in here. So what we decided to do here is, if you see the charts and how do we select the optimal contamination rate, was pretty much based on the corrected classes classified, comparing isolation force and one class SVM, as well as the percentage of population of outliers, because we don't believe that every advisor should, accept our product. It's not something that we had this particular belief, but at the same time, we wanted to get a decent amount of advisors within this decision boundary. Okay, so our contamination rate that we decide on this optimization process was a 12.5%. It may change in the future as we start, getting more and more feedback, but that's the contamination rate where we decide to go. After we decide to go with the contamination rate, this is where we start the decision now. What do we go? What do we do? Do we use isolation force? Do we use one class SVMs? And those two models can have very different behavior. So isolation force, they, by name itself, it's a tree-based models, and they tend to have tighter their decision boundaries, if you will. So what that means is they tight as some of the public information available for individuals that tried isolation force. You can see here when they draw the decision boundary for isolation force, they're a little bit tighter. They're less generalized in comparison to an SVM. An SVM is a little bit more flexible, if you will, even though you might make a little bit more mistakes as you go through the process of maximizing your reward, either your time or your money. So we had this big debate about, what do we do? Do we go very, over classifying, these individuals, and we minimize the population of advisors, or we establish the process of a little bit more flexibility, and eventually we decide to tighten the population as we go through the process. So it's a decision that we had to make. So how do we make this decision? So the idea of making this decision was using our own data. So we said, you know what, let's use our own data and see what the universe tells us, what the data tells us. Okay, so we've first of all, we decided to take all the firm data and just build that CNE, a very simple CNE. Why is this important? Because we really wanted to visualize how these decision boundaries would impact the overall population, if you will. So this is and I'm going to use the same CNE across the entire presentation, so you see how the population is impacted by the models that we develop for who and the models we develop for how in the next subsequent slides. So these are all the RIA firms plotted in 2 dimensions, of course summarized with the features all summarized by the CNE algorithm. And these are the clients in which we have feedback. It's a very, very fraction of the entire population, if you will. So it's as you can see here, barely can see here, but I decided to zoom in here and say, yeah, let's take a look at who do we have and what do we do going forward. Now, using the same chart, not changing the actual CNE results or the component number 1 and the component number 2, we decide to plot the firms in which, or to color the points in a space based on the results that SVMs was given to us, and then the points and color code depending on the results that the isolation force was given to us. So basically our hypothesis, or the known knowledge of the SVMs, are a little bit more flexible, and isolation forests can be a little bit more tighter on creating these distribution boundaries, actually true. So as you can see here, we have a little bit of points. The majority of the points are right here. Our points are still being good, well classified, of course, because we optimize using these couple points. But the goal of these models was really to find who are the advisors that are on this area or similar to these individuals that can, we can grab a better conversation for our product. So our decision was, when we look into these two charts, our decision was, you know what, let's go with the one class SVM. And the decision for going to one class SVM is, first of all, we're not well known in the industry yet. So we need to have that level of uncertainty while just minimizing some of the populations that at this point we don't believe are going to respond positively at this point. But we can always rank by score and select and adapt as we go through the process if we're not achieving the proper KPIs as we measured before, which is essentially the efficiencies on who to reach out and the more conversations, more winning at the end of the day. So this is what we decided to do. Okay, so I know that I'm talking, but I just want to make sure that there's no questions. If there's any questions, please do let me know. But we decided to go with a one class SVMs. Okay, let me just sip water. Okay, and now what? Now what do we do? Now we know who do we want to talk to. Now here comes the biggest problem for us. I was never a big fan of just finding who. Finding how you talk to is as equal as finding the who. Okay, so that's I would argue that everybody has a probability to buy a TV. It depends on the value proposition and how I put in front of you that benefit or that value in order to gain your action to buy a TV. Your probability could be high or low, given your demographics, your profile, or purchase history. But individuals today, decision-making for individuals is extremely complex. And I saw, some of these discussions on earliest presentations today, and this problem is actually not different for us. Even though we're talking to advisors that do have, arguably a little bit more of financial literacy. Of course, they have a little bit more financial literacy in general than the general population. So we decided to look at the variety of advisors that we have in the US. There's 15 or variety of firms that we have in the US. And best thing to do for us was, hey, let's work on some clusters and see if we can find different clusters or the minimum amount of clusters that we need in order to tailor our conversations and use practices of machine learning to learn pretty much what do we have to talk about whenever we go for these conversations, whenever we go to these presentations. So I saw a couple of presentations yesterday where folks talked about the elbow curve and how to define the optimal amount of clusters. And even though populations were 30,000, 50,000, I saw the clusters around 5 or 6. Let me explain what we had done here. So we basically, if we use all the data related to firms, we can go absolutely crazy. The dimension of these vectors are going to go to, hundreds. So we decided to simplify in order just to learn how do we go and then move from there. So the selection of the data we made was, okay, first of all, let's talk about firm services. So we only use, just by taking the services that the RIA firms will provide, if they provide financial planning, if they provide financial planning to B2C, B2B, or if they provide insurance advice, or there is a enormous amount of, I would say, variety of firms out there that just by using the firm services that they provide, I think you can cover pretty much some of the characteristics that we try to capture in the beginning. And the second thing is, let's talk about the general investment philosophy. What does that mean? So for us was how much percentage of their business are coming from, ETFs, mutual funds, and securities in terms of AUM, for example. So just by using these two features or characteristics, I would say the dimensions, and these two would translate probably in 20 features, if you will, we get 11 clusters, as you can see on your elbow-shaped curve here. Yes, so I was actually searching I don't think I've ever seen a population where when you have 15,000 firms and the recommended number of clusters is 11. I don't think I've seen that before, but with the ratio of, I don't think there's just anything out there that says you cannot have less than, but anyway, we decided to do just to determine where we go from here. So we ended up with 11. And if we take the same 11 clusters, and now we use the same chart that we saw before, which is using the two dimensions, the Tini dimensions, components, number one and number two, and we plot the clusters, we see that this can make sense. It makes sense at the end of the day. So there's a large representation of these clusters, number one, but these are more, there's some confusion in here, of course, but for us, what matters as of now is we needed to find who are the groups of clusters that are going to be part of our target that we need to tailor our message, okay, in a way to gain more conversations and therefore winning a little bit more with the relationships. So that's our second type of analysis to find the who. One of the things that I heard on the conversations today and yesterday and also was a very important point of any sales process when you reach into somebody out of the blue is attention. And attention is gold, okay? Especially human attention is gold. Why? Having a couple minutes from somebody it can be, oh, seems like we have a question here. See a hand.
Hi, this is Tarun. For your previous chart where you were showing the clusters, did you see anything as a function of AUM, like a certain method is preferred for RIAs with AUM bigger than a certain threshold? Like, did you see anything related to the total AUM of the firm or the RIA?
Yeah, no. We to be quite frank, yes, we saw, and that's why we decided to remove AUM, because when you think about in the universe of IRAs, you have very large IRAs with 20,000 employees and IRAs with 30 employees. So the AUM, we actually use the log of the AUM and try to transform or normalize AUM a little bit, but we decide to remove just for the sake of capturing organizations that are just getting started and do have the appetite of expanding their digital capabilities. So for this particular cluster, we didn't use AUM. We just used services as well as the percentage of investments on specific securities. Does that answer your question?
Yep, and one more question. I don't know very much about this one class SVM, but something that you were calling as outlier, how is it different than a false positive?
It's not. It's not different than a false positive. So we have to be very, very sure. So at the end of the day, when we think about the one class SVMs is what these types of models are doing is pretty much they're developing a similarity between the dimensions of the vectors in which you're feeding it, and saying who are similar, who belongs and who doesn't belong into that particular distribution, if you will. So the difference between this algorithm and a traditional classifier algorithm is you're not going to give the algorithm the open, how do I say, the freedom to choose who do not belong. Okay, so that's the main difference between these two algorithms. Most of the error functions on classifiers are y minus y hat. And you don't want to do that in these types of examples. Why? Because we only have these types of conversations. So we're basically looking at, and we try many, many things here. We try spatial distances. We try many other things that would say, who are the individuals in which we're having good conversations and how do they look like? But we decided to go with these two machine learning models just to see if we can get a little bit of more clarity on how to rank order these types of individuals. Okay.
Okay. Thank you.
You're welcome. Okay. So time check. Okay. We're good. All right. So after let's talk about attention now. So if you work with in sales before and you reach to somebody out of the blue, and you joining you say, hey, can you please take some time of your busy day and listen to what I have to say. That's why I say attention is gold. It's really important that everybody knows this. Over the last 2 to 3 years, the online presence, I would say the attention which individuals dedicate to meetings has dropped substantially. So I decided to go against the current, and instead of asking the ChatGPT, yes, I asked Google. I said, hey, what's the human attention span in meetings nowadays? And what I got was 10 to 15 minutes. So people are zoomed out. I saw a new verb coming in is, zoomed, and like, okay, what does that mean? So anyway, it's the digital fatigue of being in front of a screen. And studies shown that today a human is spending between 9 to 11 hours in front of a screen every single day. That was something that caught our attention. We said, you know what? Why do we need, if we know who do we target, why do we need the how? Why? Because of this. We have 10 to 15 minutes attention. And I would argue that we even have less than 10 to 15 minutes. I would argue that we have less than 5 minutes to convince somebody to take a broader meeting, to take a deep dive on our product. Okay. So if I don't say what you want to see it, if I don't anticipate what you need or what you see as a value proposition, there is no way that we're going to have these conversations. And this is why we decide to also think about a model or applications of machine learning in which you can simply gain attention. Because we're talking to financial advisors. These guys are super busy. Their schedule is extremely high. But there's one thing that we notice on the universal financial advisors that they really, really want. Of course, they have the higher financial literacy. They have awareness of individuals' net worth, but it's on the best interest for these advisors to really strengthen their relationship with their clients. And I spent probably 5 years in this industry before joining Wealth, and knowing for sure that the conversations between the client and advisor can go, it's interesting, can go very two different polarities. There's the majority of the population are just the uh-huhs on the phone, and some small side of the population is really asking interesting questions to advisors in order to help them on their financial situation, if you will. But unarguably, these individuals do want to increase their value proposition to their clients. So they want us, they want a partner. The problem is you have to show exactly what they want to hear. So identifying the why and how for us almost became a mandatory aspect of increasing our efficiencies. So we think about, okay, so what is decision making? How humans make decision? How, this is the psychology or behavior of industry or factors that we can extract from the conversations that we're having can influence simply by setting a personal demonstration. So we thought a lot about that, and this is still like a work in progress that we're making at this point now. But I want to give you a little bit of flavor of what's going on and what are we thinking about. So when we look at the clusters, we saw that here's the decision boundary from our model that we selected, and here's predominantly the clusters in which we're targeting at this point. So we're looking at this area over here, this area over here, this large area over here. And so we said in the beginning, is that a way that we can go in and really think about characteristics of what makes this great conversation? Is that the demographics of the advisor? Is that how open they are? Is that they heard this from somebody else? Or is that their network? Is that emotions? So we decided to think about some of these features that we can start capturing from these conversations that we're having, and eventually start a ongoing learning process. And this is what this is still a work in progress. I don't have any results as of now to share, but this is an interesting approach for us. And this is where the joint of machine learning with the individuals that are actually meeting with clients, the sales organizations, the marketing individuals, and they can provide an enormous amount of feedback or input on how you define your psychological features, if you will, and how do we better influence attention, for example. So I don't know if you noticed, but over the last, I was doing some research last week, over the last 2-3 years, the number of books that were written and published that are all about attention are massive. It's actually massive. So, if you search the Amazon's top 10 books, you're going to see at least a good percentage of books that are fighting for your attention. So do we. We're also fighting for our attention. So this is, I think, one of the hardest part is really to define, how conversations are. How do we extract these things from these conversations with advisors, the initial conversations we have with these advisors, later on take all these factors and really think about a scalable framework that we can call the treatments framework, all of these factors framework. Of course, we have the firm characteristics and all that data, but this data for us would be a very, very, very sparse matrix and a missing attribute, lots of missing, of course. And the more we discover, we can start filling out this large matrix of factors with positive and negatives to see what works, what doesn't. And then finally start establishing a process of ongoing feedback that will pretty much feed back into our models. And then just start going through the process. We start adapting the way we present our product, the way we go in and fight for a true 5-minute attention on these advisors. So it's something that we're experimenting as we speak now, and it seems to be working pretty well for us at this point. But let me go a little bit further.
There is a question, Eduardo, if you want to take right now.
Yeah.
Form?
Hi, I had a question. The data for the clusters, is it just based on the the ADV forms, or do you guys have proprietary data?
Yes, so it's 100% based on the ADV forms. Of course, we add a little bit of flavor of internal knowledge, but we needed to develop clusters that are scalable, if you will, so they can scale across the whole universe of advisors. So mostly our public data, I would say 95%. Okay. All right.
There is sorry, another question.
Okay, sorry.
What is ADV again?
Oh, ADV is the advisor's data that is available on SEC. So every registered advisor with SEC has to file a form called ADV, and the form pretty much describes the firm practices, the company details, financials, clients, and things like that. So they do have to file that to SEC, and I can share some of these details offline later on, but it's pretty much data in which the registered advisor companies have to file to SEC, and this data is publicly available.
Okay, I think John might be interested in Canadian counterpart to ADV form, right? Is there any? There is none. Sure. Yeah. Go ahead, Eduardo. Thanks.
I was going to say we can definitely definitely touch base offline, and I can show you exactly what we have done. So, okay, that's great. And this, by the way, is one of the hardest part when you ask somebody who's an expert in machine learning, how do you think the individual, how do we define openness? That's not my job, but that's why we have these individuals that are great in relationship management that can help us to define some of these factors. But this is our goal, and this is our mission for how. Lastly, this is one of the things that we talked about in order for us to move from, remember, we had data at the firm level, a lot of data at the firm level, and we had some data at the advisor level. Our thought was, how do we move data from firm level, which we have a lot of intelligence over, to the advisor level data? So because the conversations are actually happening at the advisor level, and we can't say that a firm that has 200 advisors, one great conversation with an advisor does not mean that we're going to have 199 other conversations are great conversations. So our thought process was, how do we define a advisor similarity that can basically helps us to organize, to leverage discourse or the intelligence that we build at the firm level and cascade down to the advisor level. So this is still a work in progress. Our first attempt, of course, was to really create what we call this distance matrix, and using several types of distance in order to measure the similarity of advisors. And we wanted to measure the similarity of advisors. We tried many things, just running the similarity purely by appending firm data and advisor level data. Of course, what you ended up with something, this matrix over here is pretty much comparing when these similarities agree with each other. But the most important is the contrast. What I want to show on this page is the contrast between when you purely use at the advisor level and firm data, the distance matrix, but then when you remove completely think about this, I have a vector of at the advisor level with some advisor level data and firm level data. And of course, the firm level data does repeat for advisors within the same firm. I know that I'm running out of time, apologize for that. So our goal was really to think about, and this is still a work in progress, is that a way that we can define this custom weight vector that would then helps us to multiply the advisor level data to some of these levels, and at the end of the day, accomplish what we plan to accomplish with advisor similarity. So just two examples over here. Advisors, if we give at the advisor data the weight of 1 and firm 0, you got a complete different matrix. If you use 1 and 0.1, boom, it goes back to firm level data. So this is still a work in progress that we're thinking about to measure advisor similarity, and something that we really wanted to do while just maximizing our efforts. So I know that I'm running out of time, so thanks for your time, and there's more questions.